Right. Let's brighten up a bit. All right. Well, it looks like maybe it's just, well, if I brighten up my screen, maybe I don't even need to switch that light on. Huh. Okay. Because if I go all the way dark, oops, not all that much. All right. Well, you can still see me, I guess. Because next week, is it next week? Is in a couple of weeks, this is going to be like super dark, I think, because I was checking today at 7 a.m. it was still dark, right? Which means after daylight savings, it's going to be dark at 8. So we've got to figure out. Well, I mean, I suppose I could switch the lights on also. All right. Anyway, we'll wait for the others to join us, and if you guys are interested, we can follow the same format, which is basically I'll introduce a concept. I'm going to be available to answer any and all questions about it or related to it, or even leading from it, because, we've always got to, some of us have got to keep, forging new ground. All right, so I can do that. And we'll set up a problem for you guys to work on today. How about, well, it's 8. Let's say I blabber on for 8, until 8:30, half hour. All right, maybe sooner. We can end sooner if there's nothing to talk about. But and after that, you guys can start coding. In fact, did I see the code that you guys wrote last week? Remind me again, what was the code that you guys wrote last week? It was you were doing arrays. Oh, we refactored your code. We refactored your code on Thursday. But are we done? We're done with that, right? Okay. What we can do then is this week we're supposed to talk about functions, right? Not methods and all, right? Which is regular C style functions, because we want to get an intuition about how a function works. Mind you, again, from the syllabus or course perspective, or even for most ordinary programming jobs out there, they don't need you to have a solid intuition about how a function works. You don't need to know everything about the details of function operations and stacks and things like that, and you can still do a decent job as a programmer. There are lots of people cutting code out there who don't have a firm, so it's possible, and you can pass this course too, right? However, I think it makes for better programmers if you know what happens during a function call, right? Because you're never ever going to be able to use it later in an explicit sense. Meaning that, bringing to bear your knowledge of, well, if I make a function call here, this is how it gets translated into assembly code, into machine instructions, right? In a machine instruction, your function eventually filters down and it's translated to a couple of bytes of instruction. This is, call some machine instructions located elsewhere in memory. Instead of, because, think about how a CPU executes code, right? Your program, I don't know if we covered this before, but I'm pretty sure those of you who are doing computer architecture will probably come across this. And stop me at any point if you feel this is not necessary or relevant to you. But generally what happens is every program eventually gets translated into machine code, which the CPU understands, and is loaded into memory, and it's placed at contiguous byte locations, right? That's, because that's, you don't want to scatter your program all over into memory and tell the CPU, okay, your first instruction is here and the second instruction is there, right? It's useless, So what you do is translate it into a sequence of instructions and dump it all into memory in some contiguous sequence of bytes. Bam, like that, right? That is what happens every time you type the name of a program or double click an icon, right? Essentially, that's what the operating system is doing for you. So it's going to disk where your program has been stored on magnetic media, right? Or, some kind of electronic persistent media, and it gets all the bytes from it, because the program has to be compiled by that point, right? You have a C++ program, the CPU can't execute it, so you give it to a compiler, and the compiler takes a C++ program and generates machine code, right? Now the machine code, you can't read it, but the computer CPU can read it, okay? So it's either or. So but there is a story that von Neumann can read machine code, right? I may be apocryphal, right? Because he's, people imbue him with all kinds of crazy abilities. But so you can, in a couple of generations, people will say von Neumann keeps flying around too, right? on a broomstick. Who knows, right? So all of these kinds of things tend to build up. So, so machine code is basically a sequence of instructions. It has to be a sequence, meaning that I execute this, the next one, next one, next one, and so on, right? You can't jump around usually, unless you have. So anyway, that sequence of instructions is on disk, and the operating system's job is to take that and load it into memory, and then signal the CPU, right? Saying, okay, the user asked for a program to be run. I took the program, the compiled version of it, which is your language version, and I stuck it in memory at byte address F432, right? Go and start executing. Does it all make sense? This is relevant and useful to you? All right. So the CPU will, that's the only logic that's really wired into the CPU. Well, now you got a lot of logic, but the core logic in the CPU really is go to that place where the operating system signaled us, right? F432, right? And fetch those bytes of instruction and load it here. And let's see what the instruction says. So the instruction is fetched from memory, loaded into some special stage in the CPU. The CPU looks at the instruction and says, okay, that instruction is telling me to add a couple of numbers. And these numbers are stored in this byte and that byte. I don't know, right? And then it does a sum and puts the result here. Maybe that's one instruction, right? And you have millions of instructions like that, make your program. Now, it has to do everything one after another, right, in sequence. But what happens if you have a bunch of code that is not contiguously located here, but in fact, it's being repeated many times? So you said, I'm going to take it out of there, because instead of having the same chunk of code here, 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 I'm going to take it all out because it's 1,000 bytes, 1,000 bytes, 1,000 bytes. I'm going to take all of those 1,000 bytes and store it elsewhere, right? So every time I have to run those 1,000 bytes, I'm just going to say to the CPU, hey guys, hey CPU, I want you to run 1,000 bytes of instruction, but they're not the next location, but they're out there, right? So go ahead, execute those 1,000 steps or whatever, right? In fact, I don't tell the CPU how many bytes, right? I just say, go ahead somewhere else. I've got some stuff for you to run. Okay, run that. And when that sequence of bytes tells you you're done, you can come back and then resume, as though that whole thing was just one step, right? It was a dream, right? You fell asleep one night and you dreamt an entire life, right? And then you woke up in the morning. It's a Groundhog Day. It's Groundhog Day, something like that. There was a movie like that, I think, right? So every day you wake up, it was just one day, but in that one day you had a dream that spanned, your entire life. And it like that, right? So you're stepping through one instruction at a time, but there's a special instruction that says, all right, now we're going to make believe that this instruction is just one instruction, because, there's one instruction after me. You got to keep going, bam, bam, bam. But in here, this is a secret, not one instruction. There's actually a million instructions hidden right there. In that one cell, I've got a million instructions hidden, right? Where do you find those million instructions? Go there. That's where it is, right? So go do all those million instructions, come back. Now that's one thing gone, right? So that essentially is what a function call is. All right. So we haven't talked about parameters and stuff like that, but what we need to understand is basically it's just that one level of abstraction, right? So when you understand that, then you develop an intuition. You'll develop an intuition for what to inline. We have talked about what to create, what to make into functions, what to just code, right? And so I'm going to say these, I've got 3 occurrences of 1,000 byte block, right? And I say, well, I'm just going to use those 1,000 bytes here, here, and here. Maybe there's 5 instructions, right? Five C++ statements. So you say, all right, fine. It repeats, but it's only 3 times, and I know it's never going to be bigger than that. Then you say, I'm going to use that, right? But certain times how do you know? How do you know that this set of instructions is not just going to be limited by the 15 times that I call it in my code, right? Later on in my life, I'm going to write many other programs, but I'm going to call this same set of instructions again. So only if you have that intuition, you say, well, I'm not going to use that code repeatedly, that's called inlining your code, right? Inlining your function, using that code explicitly, right? Or making it a function so that, I'm going to be calling it in general. So that intuition, you'll only get by writing a lot of functions, right? So you got to write a lot of functions, even for, stupid things. for stupid things. Write a function. Who cares? Who cares, right? So what's going to happen? Write functions, play around, lots and lots of them, right? Lots and lots of them. And then you'll eventually figure out, hey, you know what? I think this is the level of generality, right? At which I should stop repeating code. Or this is a level of specificity I should stop writing a function for and basically just code it, bam, like that in my code, right? Instead of having it call a function, because what you'll find is that once you start creating functions, there are ways to tailor the behavior of a function, right? We'll cover all that in the next couple of lectures. I mean, maybe you can, hopefully you've read the modules and you're going to be experimenting with all those things, right? So I think the problem we'll set up for you to code today will probably start touching into those things, right? Touching those things. And so what we want to do is, so it's because you can tailor your function to do slightly different things, right? So let's say you have a function to paint a room, right? And then you say, well, I've got a function that paints the room perfectly, no spots, no blotches, right? And everything. So I want to use the exact same function to paint every room, but unfortunately you don't want to paint every room the same color. So what you want to do is use the same code for painting the room, but you're just going to say, well, this one is going to be pink, that one's going to be blue, that one's going to be green, right? So you're going to tell the same bunch of code different colors, yes or no? So that what you tell that function, that little thing, is called a parameter because it modifies the behavior of the function, right? Because it modifies. Now, at the moment I think it's a basic human characteristic too, right? The moment we discover that we can control something, right? Because, well, if you accept that we can't control anything, that's fine, right? We just live our lives. But the moment you accept that, the moment you find out that you can control something, we will probe. Right? We will probe the extent to which we can control it, right? And we just keep pushing and pushing and pushing and saying, well, if I control it anymore, it's going to break, or I'm going to lose it, or something like that. And that's the point. Most people just give up. And the problem is that when you do that with your functions, when you say that your function, miraculously, I found that I can modify the behavior of the function, right? It's a painting function, and I found that I can change its behavior. Instead of yellow, I can tell it the color. Right? So I have a function that can do many things, not just one thing. I don't have a function that paints everything yellow, but I have a function that I can tell it what color, right? So billions of colors, and it'll do the same thing, right? Same quality finish, right? So you discover that and you're like overjoyed. And then you say, well, you know what else can I do? Right? Maybe I'll say, I'll use the same function, but I'll say, all right, matte and glossy, right? I'm going to parameterize that too. So I want to say color and then matte and glossy. Right, and then kind of paint, right, and who the paint comes from, and all kinds of crazy details. You start putting it in, right, and then what happens is that in order for your function to work, you have to pass this massive object as a parameter, right? The object meaning a bag of lots and lots of parameters, saying your behavior is going to be dictated by the trillion things that I'm giving you in this bag, right? Read each one of them, and it tells you what you're going to. So then it's really not a function anymore, right? So essentially what you've done is basically broken it down completely and turned it into a part of yourself, right? It's not its own entity anymore, because essentially you're telling it, you're spelling out every single detail of what it needs to do. Now, what's the point, right? So all you got is basically a robot, right? Essentially, and you're doing most of the work anyway. So the whole idea of
how do you avoid passing these huge objects into methods or functions?
How do you avoid passing these huge objects? Right. So there's two things. There's two things you're asking here. One is how do I programmatically discipline myself to making sure that the number of parameters I pass any function is not some big ass, right? So that's one thing. That is from the aesthetics and program design aspects, right? So you're asking from, that is the artistic aspect of it. But the other question you're asking is technical. You're saying, how, if I tell a function, here's a trillion bytes that you got to read. Here's a movie file, right? A movie file in 4K format. And I want you to, scan the movie and tell me every single scene in which, I don't know, some famous actor, right? Taylor Swift or someone appears, right? Something like that. And so the movie is, so your question is actually a very important question, because you're saying, now, if I want that function to read this big object. And however, it's not going to change anything in the object. It's going to read it and tell me how many scenes this person occurs in, right? Do I really need to pass the whole thing over? Take that big thing and put it on a truck and send it to that person. And so that is the technical question, right? How do I, if I have a big thing to pass to a function, and I have to, right? So leaving aside the aesthetic aspect of it, I have to pass a big thing because it's a big movie and it's just one thing, but it's a big thing, right? It's got lots and lots of bytes in it. How do I pass it to a function? Now there, and it's excellent, right? And the way, and I think that's why C++ lets you completely control every one of these little aspects of a function call, is because you have this big thing and you want to give it to someone, but you know for sure that person is not going to change it. If you know for sure that person is not going to change it, right? Meaning that you say that this is const, right? If you say it's const, that person can read it but can't change it. Yes, that's what happens to all your integers and variables too, right? If you say const int n, right? Const int pi, right? Then you can only get the value of pi. It's like the hash define that we talked about last class, right? If you say const, const float pi, right? You can only get the value. You can't change it anymore because it's const. So I have this. However, I have a const movie, right? Big movie, and I need to give it to someone and say, count all the scenes in which this actor appears. All right. Now, one way to do it is basically to load up all the reels on a truck and send it to them. Yeah. The other way, can someone tell me another way to do this?
Well, if the movie is chunked up into like tiny bits, you can pass a tiny bit in and then like return like the actors, and then
okay, all right, but yeah, all right, but still I have to keep passing all these tiny bits one by one, right? I have to open a stream and I have to stream the movie to them, just like a movie. So they have to wait for the 2 hours, right? Or I can stream it all to them fast on a big pipe, but still that means I'm sending it all to them. So yeah, but that is a solution. But tell me if there's another way to do it. No, think about it from a movie perspective. Don't think about it from a computer perspective. And let's say you are the director and you're sending the final cut to the production company, right? And so you're the director of a movie house and you've made the final cut of your film, right? And then you say, okay, now I'm going to send it to NBC and see what they think, or something like that, right? So what do you do at that point? Well, yeah, don't think about the modern days where you can email it to them and all, okay? So think about like 25 years ago, right? So they're actually on film reels. I think 25 years ago, were they still on film reels? Let's say 50 years ago, right? 50 years ago. This is definitely on film reels. So you have your movie is now composed of, I don't know, 55 reels or something like that, right? I don't know how many reels they use, but they're basically delivered in a truck. I don't know, right? If you've seen movies being made, you'll see that, they used to be delivered in a truck with the reels numbered and in metal cages. All right, so one way to do it is to basically send the movie to them in a truck. What's another way? What you want to do is get all the execs in NBC or ABC or any of those companies to take a look, right, at your film and say if they're happy with the investment of money in you, right? They give you many $1 million, right? So they want to see your movie and see if you've done a good job. What do you do? So one way, obviously, right? So imagine you're Alfred Hitchcock, right? And you got to send everything to Hollywood. Oh, well, I suppose you're living in Hollywood, so some studio. MGM, I think, right? That's one of those ancient studios, right? So Alfred Hitchcock used to work with. I think. I don't know. Because there's an MGM in India also, so that may be confusing. Maybe is there an MGM studio here? Or did there used to be an MGM? I don't know. Anyway, ABC. Anyway, they're all 3 letters, right? Pick any 3 letters. IDK, right? So there is a movie studio. I need your Alfred Hitchcock. How do you do that? Come on, take a step. Because renting a truck and sending it to them, there's a lot of risk in there, right? You're gonna load it with film, and film is expensive, right? Maybe it's your 1 of 2 copies. Who knows? And plus, if you send it on a truck, attendant, risk factors. So yeah, you want to try and minimize these things. And once you find the answer to that, I'll tell you, you'll never forget a particular C++ way of doing things, which I'll try and relate to, and then you'll see the one-to-one equivalence, right? Come on, take a stab. Zaid, are you here? Madison?
Yeah, I'm here.
Yeah, I'm here.
Come on, yeah, yeah, what would you do? So one way I'm thinking of, if I tell you, you guys are going to kick yourself, right? So yeah, so I want the editors. No, I want the execs at this movie company to see my film. So one way, instead of sending the whole film to them in a truck, is basically to say, I've rented out a theater, right, for a couple of days, right? I'm going to be playing the film there. Please come and see it. Yes or no? Yeah, and isn't that what they used to do? I think that's what they used to do, right? I don't think they used to, even in those days, they didn't used to, because if you think about NBC, they're in some sky tower in the middle of LA. They can't see the film there, right? So there's no use shipping the thing to them, right? So they'll invite them over, wine and dine them, and then show them the film and get them to sign off, right? So we spent your couple of $1 million wisely, right? So I think that's what. So in C++, you can do exactly that. Right. So if you have a function that for sure is not going to change an object, but it's just going to look at it, right? You can just mark that object as a const, and then you can tell the function, here's this big ass object that is not going to be changed by you, but you're going to look at it anyway. So instead of giving you the object, I'm going to put it there in a location, right? And here's a reference to that location, right? So if you want to look at the object, just go to this address and you look at it. Right? But here it is. So that is called passing by reference. Okay. And the other way, the old primitive traditional way of passing an object is passing the whole thing. Right? And that is called passing by copy or passing by value. Right? Because when you pass by value or copy, you're basically making a copy of the whole damn thing and giving it to them. Yeah. That's totally useless. If you know for sure they're not going to change it, why would you make a copy of big things? It's a waste, isn't it? So that's why in C++. So how do other languages get around this?
They make objects immutable sometimes.
Yeah, but how do they? What do they? Do you know what they do? Like for Java, for example, right? Everything is passed around as a pointer, and it's a clever solution to this thing, because in a language like Java, if you're just passing a pointer to an object, right? You're not passing the whole object, right? So nothing is passed by copy. In fact, in Java, if you have an object and you want to pass a copy of that object to someone else, it's really hard to do it, right? You got to think carefully about how you do it. Make sure it's deep and everything. And it's a pain. It's a pain many times. Right? And in C++, it basically says, it's crazy because the compiler, the CPU lets you do both ways naturally, right? But in Java, you prevented people from doing it one way, and then they got to do it this way by going around like that. So you can still do it both ways, but you got to go around to do that, right? But however, the use cases for doing this may be minimal, right? So those are things that you'll actually come across, right? Now you only hear me explaining this and talking about this, but hopefully if you remember this, or maybe if you bookmark this in your YouTube video later on, right? Maybe 10 years from now, when you're actually coding and you find out, right? And you say, wow, you know what? I just understood why this language does it this way and that language does it that way. And I think we talked about this in an ancient lecture 10 years ago in CS2A, right? And because many of these things, right, that we're talking about now, I think it'll just enter some part of your memory and stay dormant there, right? And it'll basically, I don't know, maybe it gets replaced by other neurons, but many times I find that when I just understand something, it basically connects to something else I found out many years ago that I thought I completely forgot. So I'm starting to doubt my theory that when I think I've forgotten something, I've truly forgotten it, right? So So yeah, all these things we're talking about, right? As long as you're not, as long as you're listening to it, I think, right? Yeah, obviously it doesn't, I don't think it would work, because if you have Zoom on and then you're checking your email or doing something else, I don't know if it works. Because I know there are some people, mostly not scientists, right, who claim that it doesn't matter even if you don't listen to something, if you have it playing in the background, like, you have a podcast in your car and you don't listen to it, but it's still going to seep into your subconscious, right? So I haven't seen any evidence of that personally. But there are people who believe that, by the way, right? So there are people who believe that playing a certain kind of music, even if you don't listen to it, makes you, I don't know. So I don't know. Maybe there's tests that you can do for those things. So that's basically it. That's basically a function call. I think we actually talked about it, right? So in the half hour before class started, we actually finished the core of this entire class, right? It's not yet 8:30, but the core of this class really, only now people are starting to appear. Hey, Fernando, are you here now really, or just turned it on?
I'm here really.
Okay, all right, cool. Great. Yeah, but I was just telling these folks that we finished our class now. No, I'm just kidding, but I'm saying that we finished talking about the core of what a function call is and what parameters are and the different ways in which you can pass parameters, right? And ways in which we've been doing that in many languages, right? And the way that languages handle them in the back end, right? So for example, in Java, parameters are always passed by, pointer, which is kind of like references. You never, right? But then it becomes horrendously hard in Java to pass things as constants, right? So you can never trust a function completely.
Yeah, true.
Right?
Yeah.
Yeah, so you have to be, you have to trust a function completely. I think that's, yeah, right? So you have, in Java, when you pass something to a function, you have to trust the function not to mess around with your object, right? And things like that. So a programmer needs to be a lot more careful and a lot more knowledgeable about what goes on before they become really, really proficient in Java, right? Because in Java, you can cut code, right? You can get cut code, I think. But in order to be really proficient and know exactly what's going on, I think a programmer needs to progress much further. Or maybe if you're saying it the other way, I think you won't be able to be productive in C++ unless you know all these things, right? So when you're productive in C++, you already know all these things. But in C++, you can explicitly say, right? So this is going to be passed by as a const. So I don't want to trust myself to write a function that won't mess with it. Maybe I accidentally mess with it. In that case, I want the compiler to catch it and tell me before it goes to the CPU. Right. And so, and even though eventually you don't make these silly kinds of mistakes, but it's good to have these behind you. Right. So it's like saying, you train really, really well to be a fighter. And you say, I'm such a good fighter now, I don't need any armor. Right. So people don't do that. Right. So even though people are good fighters, they basically go with, the best kinds of protection they can already get for free. And then they put the best fighting on top of that. Right. So, speaking from, a story point of view and all. But so I think that even as programmers, with C++, I think having the full power of C++ behind you maybe makes you a better programmer in many ways, because you don't have to trust yourself anymore, right? But you don't have to trust yourself for stupid things anymore. Right? So you can trust yourself for the more serious things, the things that really require your logic and thought and creativity, right? You can shift your attention there instead of having to worry about housekeeping, right? Because if you think about it, a lot of what we do, right, even in our lives, a significant portion of it is devoted to generally housekeeping. Not housekeeping, I don't mean washing the dishes and things like that, right? Housekeeping meaning, our ability to keep ourselves going so that we can enjoy life. Right. And then we spend an inordinate amount of time, right? 20% and then 80% to enjoying life. That's good. Right. But most people do 80% to maintaining themselves and only 20% to enjoying life. Right. So like that, I think what happens in programming. So I don't know how we got. Yeah, that's one of the reasons we shouldn't digress. Right. Because there's more likely I could lose my track. What are we talking about? Functions. Yeah, C++. Having the power of C++ behind you. Yeah, so it says that, because I have such a trustworthy backend, which would not allow me at all to do what I want to do, right? The fact that I'm doing what the fact that I've passed C++, the compiler, means that I can be confident enough to disengage my mind from the 80% of stuff that it might otherwise worry about, and then shift the whole all cylinders to fire on the creative aspects of what I'm doing, right? And I think knowing that, because I don't know, so when I used to program in Java, I think I used to be a lot more careful. I mean, I don't know. It's also how you think about things, right? But in Java, there always used to be a niggling concern for me, right? Niggling concern. I don't know. Maybe I stopped extensively doing stuff in Java. I still do it from time to time. I mean, next quarter I got to do it, right? I'm teaching Java, but there's always this niggling thing in my mind that I have to go through jump through extra hoops to make sure that I can't take certain things for granted in Java like I do in C++. And so I have to, there is a feeling in me that I cannot bring my 100% to bear on a right. Of course, I mean, later on you can think about in Java. What I mean is that the logical, the creative aspects of it, that's fine, because you're not even thinking of programming then, right? But when you try to translate it, I think it's more of a pain to code it step by step without knowing that your previous step makes your next step a whole lot easier. Right? I think that's the thing, right? In C++, what happens is that, you code it step by step, your entire project, but everything you do, make sure that the next thing you do is going to be a whole lot easier, because this will take care of a lot of automatic things. So everything, and I think I never reached that point with Java, no, at least not as much as I did with C++, right? In C++, you can actually just get all the way down, because it boils down all the way to the level of a machine. Even in Java, right? But even in Java, you can boil it down all the way to the level of a machine. But the language itself makes it hard to get certain features that you pretty much get for free in C++, right? And in Python also, right? So Python is good for certain things, just like Java. Is it interpreted, right? It takes Java to the next level, really, right? Because Java is bytecode interpreted, but Python is actually text interpreted, right? Like JavaScript, right? So it's the same program that a human can read can also be read by the system, right? Not CPU, but the system, because the translation from human readability to CPU readability happens line by line, right? Or block by block, because the interpreter, the Python interpreter, reads, right? Whereas Java is just one level closer to the CPU, right? Because it takes that and digests that into some Java intermediate code that only the Java, runtime system can understand. So all those funky details. And in fact, you go all the way to Chrome, right? Chrome or Safari or JavaScript, right? And and you have your program running. Your interpreter is built right into your browser, right? In fact, if you're running Chrome, you can just command here Shift-J, and you can just see the JavaScript interpreter right there. I'll show you at some point when one of you is sharing the screen, right? So yeah, so and then I think that's how you get really conversant with programming, is not just by learning one language, right? Even if it's C++, right? C++ shouldn't be the only language. Although I do believe now that I think this is the trajectory I would pick for a very young person, right? Venturing into C++, programming. I would say in the very beginning, they should just try visual programming languages, right? Like Lego blocks, and I don't know, the MIT has these things, right? So do these things, or even play with blocks at home, trying to do these logical things, right? So very, very young. And then, and also, we make sure not to discourage logical thinking, right? Which a lot of people do, right? And then later on, I think the first language, I think, right, should really not be Python, not be Java. The first language should be JavaScript, even though JavaScript is ugly and it has a lot of features that experienced programmers find painful, right? Their first language, I think, should be JavaScript, mainly because they can get very immediate gratification. Their gratification when you're young is really, really hard to think about what's going to happen like 10 days later, right? So they need to type something into a browser and see the effect immediately, right? So JavaScript is very good from that point, right? Because they can have a screen, right? And they can open a JavaScript console on the side, right? And maybe the screen has blocks, and they type in a little JavaScript function, very simple, and the blocks rearrange themselves or fall down or something like that. Very simple, and they can do that, and they can see that. So having people get used to the fact that they can control the computer in a predictable way, right, one after another, and then leading them to take that block, those blocks, and so I think there are games out there that already do that, right? So that's why I think JavaScript's next. Once they get used to JavaScript, they can try Python, I guess, right? Because that's also they can read and they can follow along. I think the next step should be Java, and finally they should never somewhere along the line they should definitely see C++, and then different paradigms of programming. All of these, from the beginning, they're all procedural languages, right? Because we haven't even started talking about other paradigms of programming, right? Programming is actually a fantastic science. It is very fascinating because just within procedural programming languages, like we're doing now, there's so many of those, right? So many families and so many of these, right? And all of this we've talked about now, all these languages are all procedural, right? Even object-oriented procedure, one after another, right? This is different paradigms. Some programming languages are, maybe the visual languages are completely different, right? Visual language is what kids start with, or even advanced programmers, like when you do blueprints in Unreal, right? So that's a visual programming language. But there's other paradigms of computing, like Prolog. It's declarative, right? Where the way you declare your program is fundamentally different, right? Where you write your program is different. The way you think about the problem is slightly different, right? Not entirely different, but the way you think about it is slightly different. So, but the thing is, we should not force ourselves to force ourselves to learn each one of those paradigms for the sake of it. And I think that is a mistake that I did. But fortunately, I broke out of it. But I think at one point, I just as a student, I just thought that it's good to learn as many different paradigms of programming as possible, right? Rather than different ways of programming. So I learned functional languages and this, all these kinds of continuation, and just for the sake of learning them. And so I know what each one of these things is, and I found that that really didn't take me anywhere. Right, it was useless for me. I knew where every single nut and bolt was in the workshop, but I could not do anything with it because I didn't have an idea of what they were good for. So I think the way to do it is just start building a car or building something with what you know, right? And then in the process of doing that, what you realize is that, wow, you know what, I've done this so many times. Maybe there's an easier way to do that. Maybe there's an easier way to think about that. Right, and then you start thinking about that, and then you find maybe some other person has thought about that. Let's see what they've done, right? So maybe I can borrow some interesting things from that, right? Or course correct, or or adapt, things like that, or come up with something new, right? But that's the way to learn a completely new paradigm, I think, because if you start programming for a hobby, right? If you start programming for a hobby and do lots and lots of coding, I think what we do is eventually come across situations where you want to apply multiple programming paradigms, right? Even if it's something like, what is that, thing that is really, really thin, that there was a system for TCP/IP. Is it Erdos? Is it not Erdos? Some language. I don't know. I played very briefly with it when I was at a company. So it makes incredible number of TCP connections at once. It could be fielded. Like connection from computer to computer, right? Incredible number could be fielded with very minimal overhead. And I think there was a company that became very, very successful and sold to Facebook for a huge amount, right? Some $19 billion or something. But they were based on this because what they did was, traditional ways of routing packets on the internet was really painful and had a lot of overhead. So they came up with a stack that was really, really, or a program. They exploited a language which had a very thin stack for that and could do like trillions of connections, I think. I don't know, something like that, exaggerating, with very minimal overhead. And that's how that, they were able to do this massive thing. I think, I don't know. That's the story anyway. I don't know if it's true. But anyway, so I think that's how these things happen, right? So you find different paradigms of computing suited for particular niches, right? So you say for mathematical computing, this is a paradigm that works, right? For logical, propositional computing, or machine learning, that's the paradigm. So each one of these has develops a completely new family of languages, right? And a paradigm of computing, in fact, a way of thinking about it, and that's only this century, right? So after a couple of centuries, these ways of these programming paradigms will be so different from each other that they'll be like completely different languages altogether, right? Because right now is when we're starting with the root language and it's starting to bifurcate, right? But think about human languages. And so when each person, when each of these areas start specializing these languages more and more and more, in a couple of centuries, your grandkids, programming in XYZ will say, that is impossible. ABC is a completely, it's a different world altogether, right? So they'll be so different from each other, like learning, I'm pretty sure, right? Or some grand unification where you say humans don't write any programs anymore, right? Humans basically think what they want, right? And everything else is taken over from then on, right? So you just think about what you want to do, and at that point onwards, scanners placed at intelligent locations in your brain, in your home, will basically find your thoughts and program it to happen precisely the way you want it in your brain, right? So with absolutely no difference, right? All your nutrients taken, you become a brain in a vat. Like your philosophy professors are fond of quoting all the time, right? So anyway, I think we've waited long enough. We should basically start. If you guys don't have any objections, what we should do is basically take the program that you wrote last week. One of you, hopefully, Yushin, I think you are in front of a computer today. Yes? Are you in front of a computer? I can't even hear you. Okay, you got to get in front of a computer. You got to start coding, okay?
My computer is on the way to me today.
Then you got to get to campus and find a computer. There's lots and lots of rooms with computers.
Yeah, I sent my computer to Best Buy Repair, and it
All right,
will
so
be...
next class, you got to go to campus. All right, sit in the STEM center. There's like tons of computers there.
Oh, okay.
All right, so find a corner in the STEM center or move a computer into one of those rooms where you can basically talk and attend class from there. That'll be a whole lot easier for you too, right? And those computers are nice. Those are much better computers, I think, right?
Okay.
So, but you should code. If you don't code, you're going to drop out of this class.
Okay.
Okay. All right.
Okay.
Who else? Hey, Zaid, are you still in your bed? Zaid?
What is that?
Mm-hmm.
You are in your bed still?
Yeah, I'm in my bed. I have my computer.
So you can code?
Yeah.
Okay. All right. So you want to code?
Sure, I guess.
All right. So someone shared the link. I think who shared? Lay shared the link. Where's Lay? Lay's not here today. All right. So someone shared the link. So pick up the code from there. And I think what we'll do. Hey, you know what? I overheard the comments. Someone said towards the end of last class that I think it was Agnes. She said she had a hard time following this code because there's so much code in there and it got cluttered, and then so many comments and lots of things got cut out and all, so she didn't even know what to. And I thought, oh my gosh, that is so true, because even when I go and watch the video, I can't, it's hard for me to tell, even though I was talking to you through most of the code. There's so much in there that's commented out and overridden and things like that, so it's a pretty useless video, I think. So what we'll do is basically start from scratch, and then what we'll do is this time, and if I don't do it, someone remind me, okay? Let's put a comment about above everything we do, and then move on, so that someone who's just following the code can also see it, right? So if Agnes or someone follows the video, they can basically look at the chunks of the code, things that you're doing, with comments on top, right? Saying, okay, in this chunk we're going to do this, right? When we're done experimenting with that, you can basically say, you can make a block comment. I showed you how to make a block comment, right? So when you're done experimenting with a block, you can basically make that whole thing a block comment, okay? So this was experiment number 1, we tried this, okay? And you can put a comment there saying that's what we tried. If you want to try that yourself, move that block comment end marker right to the top, so that is uncommented now, so you can basically run it. So every time you start lengthening your program, you can basically have chunks of those block comments one after another. So we're going to experiment with that when it's done. All right, so we comment that out, go on to the next one, right? And also just do one chunk at a time, so that you don't skip around from here to here. I think it throws a lot of students off, and they're finding it hard to. I think they find it hard to follow. So I want to make sure that everybody is on the same page and everybody gets a chance to code. Okay. Hey, and some of you are absent today. I don't know. you guys should hopefully have some channel on Discord or Slack where you guys get together and talk, right? So you got to make sure that everybody knows, right? That participation is important. You got to come to class. And in my class, you actually do get to code and you will learn something worthwhile. Okay, so that is the most important thing. If you come to class at the end of 2A, you'll find that you have actually learned a very important skill that can make a difference in your life, right? And you'll want to learn 2B and 2C so that you can actually go out and kick ass, right? If you finish 2C, right, most of the people who actually ace 2C all the way, right, very small, right? I think less than 5% of the people who start in my 2A and go all the way to 2C will ace all of the quests, right? Ace all of them from the beginning to the end. But those guys, I think basically just, they're set up to kick ass if they want, right? They're on par with the best programmers at the best companies out there. I know, any problem, you pick random people out there and they will give it, that kind of effort, right? And likely find a solution to. So I think that if you bring that mindset to bear, I think that by the end of 2C, you will be in a position to create something really good, right? You create something really good that other people would be interested in using or buying, right? So, and I think, and I'll be happy to guide you, right? So I've done a lot of these things. So I can guide you. It's not a great deal of effort to make these things and release them, right? So, and try out, then make these things, release them and see what happens, right? See what people think, is it useful, right? Are people having fun? All of those data points are useful to get when you're younger, right? So that you can actually store all that and it'll inform your judgments later on. Saying, when you're, let's say when you're 35 or 40 years old and you create a product, you already have a lot of data in your head saying, when I was a teenager, I tried all these things and I know how people think, I know what people want, right? Now, you don't want to take $2 million of my money, right? And then say, I'm going to do a market study and find out what people want, right? So VCs don't care about, funding you if you're at that stage thinking, I have an idea, I want to find out if it works or not, right? All of that should be history, right? Meaning that you should be doing that now. So do that, get rid of your experimentation, trying out things, finding out what people want and all those things, so that when you hit, late 20s, right, you're ready to start a company because you know what people want. And so I think, I don't know how we got started talking about that, but I think, yeah. So you got to attend class. You got to attend class, and by the end of 2C, I can help you. I can help you create things, right, on your own. It's very easy. Whether it's an mobile app or an Unreal game, right? I don't know Unity, but or C++ code or a web app. I can help you, right? I've tried these things. I've played around and helped other people, so I can do this. Or something on the cloud, which that's a web app basically. You can something like that. But you got to stick through, and if you ace 2C, I can even fund you, right? If you finish 2C, ace 2C, and have a really interesting idea that you want to work on, and you have a good plan for executing on your idea, I will be more than happy to seriously consider funding you, right? Well, not like trillions of dollars, obviously, right? But like a seed investor, I'm happy to. But only that offer is only open to people who ace all the quests up to 2C, right? So there you go. So there's a great incentive for completing 2C and working on the quests really hard, because once then I can be confident, right? So anyone who's done 2C really that level, I don't have to think so hard about investing in them, right? So if they need a couple $100,000 to create a product, I know what they bring to the table already. All right, so I know that they can build these things. I know that they're not going to take, they're not going to pay $50,000 to a contractor halfway across the world, right? And have, back and forth on a loose product, right? That's a total waste of money, right? So that's why you find a lot of VCs too, right? You go, I know, right? Many people even, they go begging and saying for $1 million and $2 million, they go begging, right? But if you look at their pitches, useless shit, right? Because they want your money to take a risk that they would not take with their own money, right? Even disregarding disregarding the relative, scaling things down appropriately, right? So basically, they want you to take a level of risk that they won't take, right? And so that is the reason for that, is because all of these risks are safe to take now. When you're young students, it's safe to take now, right? So if you take these now, you don't have to go begging for lots and lots of money to take those risks later on someone else's panic, which is not fair also, right? So that's really what happens when a VC turns you down, is really saying that, that's too much risk for me, not so much risk for you. That's basically what they're saying, right? So you got to even the playing field out, and they'll be willing to listen. But so that's why I'm happy to do a seed stage investment in you if you progress all the way and ace all of the quests, right? All the blue quests, all the green quests, and I'm following along, right? I know every single student, and I know exactly how much effort every single student is putting in, right? Both my 2A and 2B, I know every single student, right? I'm not just saying this quarter, right? This quarter in my 2B, it's I got to look more. I'm looking and looking and looking. I've got to look more into why a lot of students are finding it really, really hard this quarter, and it didn't used to be the case before. So so my class is much smaller, right? It's in 2 digits. It's just like what is it, like 12 or 13 now? But usually I have my really strong classes in 2B and 2C also. And so, but even then I used to watch the progress of every single student, right? So you can come to me and ask. And next quarter, I think I'm just going to make it, discussion hour every week, maybe for 2B and 2C, right? Like mandatory lectures we have in 2A, right? Even though it's online, I'm going to say that you have to attend the discussion hours to get participation points, right? Because then you can force students to work on these things. Otherwise, I think what happens in online courses is that, and you can correct me if I'm wrong, some of you are enrolled in online courses and you have friends, but you enroll in it and then you forget about the course until it's time for something that's due, right? A free state or a midterm or a final. Then you pick up your books and you read it, and then it's harder, right? It's much, much harder than if you do it one day at a time. I think that's what happens with online courses, is that, just before the midterm or free state, they basically, dive into the quest and they find that they are totally out of the depth, right? And I think that contributes. But I know how much work everyone is putting in, and that's fine. I'm willing to help. If you ask for help, I'm happy to help. The only help that I'm reluctant to give is secret help that would be a disadvantage if it was offered exclusively to one person, right? So I just want to keep the playing field level. So I'm happy to help anyone who asks me these questions that are relevant to CS2A or programming in general, right? Or if it's out of class hours, I can help anyone with any problem that I know a solution to, right? Maybe it's a life problem that I've overcome, and I'm happy to share the solution and things like that. Our counselors are free. You guys are paying for our counselors for free. Yes, your fees, your Foothill fees, some big fraction of it is for Foothill counseling, right? Whether you use it or not. So you can actually book an appointment with our counselors. You get free counseling, right? So imagine how much money people pay outside. So you can go and talk to them, and you can even complain to them about professors. And it's all confidential, right? They don't pass any information to us. That's a good way to get us feedback, right? So you can go to the counselors and say, well, I'm having a difficulty with this course, right? How do I, and I can't talk to the professor because the professor, is always blabbering on about nonsense and not listening to me. So yeah, and then the counselor will tell me, right? We've received reports from students. We won't know who it is. And so that's a good way to do it. I'm happy to help you anytime, right? I have a lot of time right now, fortunately, because I'm in the process of automating some of the routine tasks we do in some of our departmental and meeting related things. So that's freeing up a whole bunch of time. Plus, I'm guiding a couple of past students through some projects. That's taking up a bit of time. But other than that, I still have time. I have some time. They're the personal projects, right? They're not even related to Foothill. They're personal projects, and I'm happy to guide you through personal projects too, right? This one is a personal project. And the student was interested in doing something as a personal project, which will also be useful for Foothill. So that's really cool, isn't it? It's a past student, not a current student, a past student. So that was really cool. And I decided, yeah, okay, yeah, let's just get together for an hour each day or something like that, and walk through some code, and then you can go off and do more and get back the next day. We'll code together again. So that's what we're doing with a couple of students, I think, and I'm happy to do that. I'm happy to do that with C++, just not quests, okay? And don't ask anyone to debug your quest, but you got to keep on banging your head on it, okay? And inure yourself to that feeling. And then you'll find it's all worth it. So I'm happy to help you. Ask me, ask other people, but you got to keep coding. Keep coding. All right. If you don't practice, you will not get good at it, right? So that's what they tell you in all these other art classes, right? If you go to our ceramics class and enroll in our ceramics 101, Andy's not going to just give you a pass if you don't show up and sit on the wheel at all. Right? He's going to sit down next to you and watch you make a pot, right? And he's going to feel the side of the pot as you're curving it and see if you get a curve or a jagged edge. And those are things. And if you say, I know how to do it, I've seen like a million YouTube videos and this is how you do it, right? You have got to move your finger at 30 degrees angle. And you tell him that, is he going to give you like a pass mark for that? No, right? So programming is like that. It's not like math, right? It is like math in that way, right? Even in math. Right, in math, imagine, right? If you tell a math prof, Patrick, right, and you tell him, hey, Patrick, you got to give me a pass in discrete math because I can prove that sum of the first 10 numbers is n times n plus 1 over 2, right? I know it's true. I can prove that. It's an identity, right? So is he going to? No, he'll say no. How do you know it's true? Can you prove it from first principles? Use math induction or use some other method. Show me that you really are convinced. And that's how we do it in computer science. So a lot of people just enroll in computer science in formal courses, right? I find that if you manage to put things together, you can't just come and get a pass, right? You got to come and show that you know how to do these things, right? And so please stick with this class. I'm happy to put in extra hours if you want, because all I want is to see many of you in my 2C class. I want to see many of you say that I did the whole thing. I did the blue, green, and the red quest all the way through, right? There's only very few students who've done all the way through, right? Some have done only the green and red. Some have done only the red. Some have done only the blue and then gone away, right? And I think about 1 or 2% of my students all the way from when I started questing in 2019, right? So I started, the first quests were offered for 2A. The first quest were offered for 2A in 2019, fall 2019, along with my cloud class, right? Because I created the questing as practice for learning the details of clouds, AWS clouds, right? So it was basically the questing system was my practice, but then it became like a fully fledged, massively scalable system on its own, right? Very easily too, using all the current facilities. So it's like on par with any other global service like Google or in terms of availability and billion people could be hitting it at the same time. It's automatically scaling. So, and it's cheap, right? Because in terms of CPU power, we don't use a lot these days, right? So 2019, since then, I don't know, only maybe 4 or 5 students have done all the way from blue, green, and red, right? And 2 of them have done blue, green, and red during the same quarter. They wanted to do red, and they earned the password for red by doing blue and green, right? So they did blue, green, and red in the same quarter. But I think the rest of them basically did them in the respective quarters. They did blue one quarter, green the next quarter, and the red. So I would really like all of you to do red, all the progress all the way to red, right? And hopefully even do a product. And I'm more than happy to help you. All right, it's 9 o'clock. You guys want to start coding? Who wants to pick up the screen? Zahid, pick up the screen. And then let's just say, what we'll do is not copy and paste from the last lecture's code, but instead keep that as a reference in a different window, and you can copy and paste the bits that you want. Is that a better way to do it? Just open up an empty editor. Okay, share your screen, empty editor. Or what are you using? Xcode or VS Code? You said you had a Mac, right?
Yeah, no, I was just gonna use online GDB.
Okay, yeah, that's fine.
Okay.
You're using Chrome? Just make sure you have a. Can you just exit Chrome for a sec? Just open a Command Shift N and open a private window. This is not private, right?
This is private.
It's not colored like a private window. What does it say? Is this a private window? I don't see that man with a hat. Where's the man with a hat?
I have it right here.
All right, hit Command Shift N.
I did. I'm in a private window right now. Here, hold on.
Wow, is this Chrome?
Let me just stop sharing and then I'll reshare my screen because I think it's.
No, that's okay. That's okay. Is this Chrome?
Yeah. Oh, I think you're on the. I think I created a new tab and Canvas is no, not Canvas. Zoom's not picking it up. Here, wait.
Oh, you're not sharing that tab. I see you're sharing your old tab.
Yeah.
Wow, I thought that Chrome basically issued an update in the last half hour.
Yeah.
Before class, I checked Chrome. The coloring was different.
Yeah, here. Okay. Let me share this. You see
Yeah,
that?
see that's the man with the hat. Yeah, that's what I was looking for. Okay, all right. So go to online GDB. The reason I say that is because sometimes you have autocomplete in your URL bar and things like that, and maybe that exposes a quest password. Who knows, right? So I think the quest password is part of the URL, isn't it? I think.
I'm not sure. Maybe.
I think so. I don't know. Maybe it's such a long time I've forgotten. But anyway, so yeah, go to online GDB and then we can start. Someone send me a couple of chat messages. Hey Zaid,
Yeah.
are you doing online GDB? Go to online GDB.
I am on. Wait.
What's going on? I'm not seeing your screen.
I have
I can see a mouse. There you go. Now I can see it.
I was on the wrong tab.
All right. So yeah, now delete everything except also above all the comments on top also. Yeah, thank you.
On top.
Yeah, remove the comments. So what we'll do, guys, is, and then you're going to fill it in, okay? Like all of you guys, right? And not just Zaid, right? Zaid, you just type, okay? Let's get before you type, ask someone to say, what do I type? What do I type? And then someone will just tell you, right? And take feedback from multiple people. That way you can force everybody to be involved, right? The goal is to have as many people involved as possible, okay?
Okay.
Okay, great. Now I can see the screen and.
So who wants to start off?
All right. So here's what we want to do. Let's say we want to create a function today that can take an array, a vector, right? It's going to take a vector. And I showed you how to create a vector. Yes. Let's not use native arrays anymore. We played around with native arrays, to our heart's content last week. Yes. I hope. All right. Okay, good. So what we can do is we want to create a hash include vector at the top, right? After IOStream, say hash include vector.
Okay, so above or below?
It doesn't matter. By convention, people put it below because they want hash. I don't know.
And what was it called?
Vector. It's just vector. No, it's not. Don't say it. Yeah, just say vector. All right, that's it. Okay, for the space. Oh, yeah, and so that means you also have standard colon vector now. You can, if you choose, let's try it today without using the namespace, right? Because namespace, it's okay to use it in a source file. It's never okay to use it in a header file because then it automatically becomes used in every single file that includes that header file, right? But we'll try using it, not using it even in the source file, which means that we have to explicitly qualify our cout and vector and things like that, even string. Okay, so put a comment above main, and say, yeah, and put a blank line before that too, so you can, it's above that, yeah. A blank line before that, right? Now the comment, you should say, create a function to take a vector of let's say ints. That's a vector of ints, and return the average. Yeah, Okay, so basically you can copy and paste. If this is not what we coded, I forget, right? If you did a different function like calculating min or max or something like that, you can just change the comment too. But essentially what you want to do is, here's a signature of the function on the next line. You can say returns an int, int. You can in fact say return long, right? You say it's a big integer, right? Long.
Wait, where do you want me to type it?
Long, long, space, get underscore mean, right? You say get mean, right? It sounds so bad. Say get average, AVG. Instead of mean, say AVG. Yeah. All right. Now, as parameters, now this is a function, right? This is a function signature, and you should probably spend at least 10 or 15 minutes just looking at the function signature and thinking about, or even discussing amongst each other. Hey, what does the ampersand mean? What does it mean? What does it actually have? What's actually happening, right? And things like that. It's actually interesting discussion, right? And you can always yank me back and ask me questions if you want, right? The first parameter after open parentheses. And the first parameter is going to be a vector, but we aren't using namespace. So you say std : vector, right? We have to explicitly qualify our vectors now.
STD what? :
: yeah, vector. All right, and then angle brackets. And then no angle brackets, and then yeah, there you go, right there. Angle less than sign. No, just one, not two. Right, this is how you create a vector, right? And I know we haven't done templating and things like that, which in fact has to wait until CS2B, I think, right? So but still it's useful to learn about vectors and templating vectors because we use it so many times. So what we're saying here is give me a standard vector of ints, and the way you do that is std : vector less than int close greater than, right? Say int there, int, and then close the angle bracket, greater than. Now get rid of all the spaces and get the vector all the way up to greater than, yeah, right? So that's one token. It's technically it's not one token, but we can think about it is one unit, saying that I want a vector of integers, which is the same as an array of integers, except that it has a lot of nice things, right? You can say now inside of the closing parentheses, we still haven't completed it. Now type in ampersand. Right, Shift 7. Now, why do we do this ampersand? That is something for you to look in the notes or Google and find out. We talked about it already for at least 20 minutes before the class started, before you start coding, right? So the ampersand right there, space. In fact, I put the ampersand, put the space before the ampersand, put the space before. Yeah, it's just style, right? You can change it if you want later on. Now, what we want to do is this is the parameter I'm giving to this function to say, give me the average of all these numbers, right? So you say ARR, right? Or call it VEC, VEC. Yeah, all right. Now, yeah, and then after the closing parentheses, space, and then open a brace, open it, and then next line. And here you say long AVG, right? AVG, right? Semicolon, right? And then enter, right? And then make a comment there saying, stick in a bunch of code here to calculate the correct value of AVG from the past VEC.
So stick in code.
Stick in code to calculate the correct value of AVG from the given, I think, yeah, VEC, right? That's all, right? I put in a, yeah, I think the comments look great, right? Yeah, next line. And then this part you're going to do, right? So a few more lines here. In fact, you can say, to indicate to you that you're going to do this, put in a comment there saying comment, double comment, and then ellipsis, comment, and then ... meaning that you're going to fill it in now, right? ... Right, so you're going to fill it in, right? Now, a couple of, just before the closing brace, you can say return AVG. Right, semicolon. All right, so what it's doing is that it's declaring a variable called AVG, calculating the average using code that you're going to supply, and then returning the value.
Yeah.
Okay, now there's a bunch of subtleties here, the ampersand and then vec and the declaration of the function. That is something that you're going to, research and find out. There's lots of notes, right? Even in our class notes, there's a lot of notes, and we talked about it too. We just find out and link the concepts together, right? That's how you pass by reference and things like that, right? So you can do that. In fact, we'll do one more thing here, because we know that vec is not going to be changed. Yes, it's just going to calculate the average. It's not going to change it. Yes or no?
Yeah.
Okay, so tag it as const before the std double colon vect. Yeah, say const before the std double colon vector. Not there. On line 8, not there. Before the std double colon, right? You have that. Yeah. There you say const.
So what
Space.
happens? Like, is there like a compiler error or something if you do something wrong?
It'll tell you what you need to do, right? If the compiler throws an error at you, it'll basically say, right? For example, let's generate a compiler error right here. Yeah. Say try and say vec of 5 equals 10 or something like that. In fact, it's a dangerous thing to do, right? Because we don't even know if vec is 5 elements big. It's a vec of 0 equals 5, right? Assign something to vec of 0.
Okay, so
Just say vec of 0, vec of 0, square bracket 0. Square bracket 0 equals 0, right? So basically, it's just assigning a value to it. It's dangerous, right? We don't even know if vec is empty or not, right? And we're assigning to it. However, we told the compiler that it's const. Yes, Alexandria. So now, if you try and compile it, it's going to complain, saying you're trying to modify something that you told me was const. Is that the kind of error you're referring to?
Yeah, thank you.
All right. So let's compile this. Oh, you already did it?
yeah.
Okay, all right. Well, it says assign is an error assignment of read-only location. You know what? Let me get my other glasses. So especially, red on black is harder to read. It's not even crisp red, right? It's basically fuzzy red. Oh, that's actually bad. It is actually crisp. It is crisp red. It was fuzzy red with my other glasses. All right. Okay. Cool. All right. Assignment of read-only location. Yeah. Okay. So that's basically what it's saying. Read-only is const. It's saying, you told me vec was read-only, you told me it was const, but you're assigning to it. So the compiler caught it for you. So that's a compiler error. So basically, that red ink is basically, it has our back, meaning that now you can feel confident that the compiler will catch these kinds of things. You don't have to worry about those things anymore. That's what I meant before, saying this red ink is actually good for us, saying the compiler has our back, saying it will not pass this code. What if that code actually changed vec and this guy main wasn't expecting vec to be changed, right? That's why it's a const, so it shouldn't. So does that make sense? Do you have any other question? Yeah, you can complete the comment, Zaid, because I think future other students may, especially Agnes, right? She might read it and doesn't work because we declared vec as const, because we and doesn't work. Doesn't work enough, or we should generate compiler error? No, it doesn't work is fine, because she's going to try it and she'll find out that it's a compiler error, right? Or she or whoever, anyone else. Does that make sense? You're going to write that code, and so instead of return average, now you can basically say return comment out return average, right? And then on the next line you can say return 0. That means it's a stub, right? Return 0. And then what I do is, because it's a stub, I basically put 4 comments, 4 forward slashes right on there. So on the same line, I say 4. So that means I can basically search for those places which has 4 of those, and then I find those useless lines or stubs, right? You say it's a stub, the stub return value. You say stub return value, stub return value. That's what a stub means, right? Stub means it's a value I'm sticking in there so that the compiler won't complain for now, but I know it's got to be changed with the correct value later on. Does everybody understand? So that's how you build bigger and bigger systems, right? Many times what happens is that as you start building bigger systems, you'll write stubs for lots and lots of your sub functions, right? And some of those functions may not be simple functions, right? Some of those functions might actually be entire programs in their own right? It may be one simple function. That function calls other functions. So maybe it uses a data structure that's really complex, but it's only 5 lines. So that function itself could be an entire project. So you write a stub and use it, but then you're going to outsource it to someone, maybe on Amazon. At Amazon, you can buy engineering talent too, right? To support. or somewhere. So you some other country. So you can outsource that and have them do that within the parameters that you dictate, and say, I'm using a sub right now. I'm returning the value 0, right? But after your system is done, and I give it this input, I expect to be given back pi cube over 47, something like that, right? Some extremely sharp number, so that you know their system is working. So you can give it, I'm going to outsource this to you. Here's like a couple $1,000, right? After you're done, I'm going to test it with my own test set. I'll shoot like 5,000 numbers at it, random numbers for each one of which I know what output I should expect, right? And some of those numbers will be, badass numbers, which you never expected. Maybe you never expected negative numbers. I'll give you negative numbers. If your system crashes, I'm not going to give you the rest of the money, right? So I'm going to give you all kinds of unexpected input, but you, and also time your system, right? Because if you implemented that using an exponential algorithm, no money for you, right? So I want you to implement this, sub-quadratically, using this much code with, these test sets, test sets that you won't know, right? Lots of really brilliant people are up there waiting for chances like that, right? They'll take you up. Even if you don't give them money, they'll jump at the chance many times, right? So, and that way it'll free you up, saying, okay, I've got a really competent person or a competent team working on the sub problem, right? And they're going to interface with Sage or do some REST calls here and there and so on and so forth. They're going to build some complex system, right? But eventually, I don't care how they do that, but I know they're going to do a good job. What I'm interested in is basically just the behavior of the function for these, these inputs, right? And I'll make sure these inputs have, out of bounds too, so that their system doesn't crash. So that's exactly, if you remember, maybe you haven't come across this so far, but in questing, that's eventually what questing will turn into. Right. Even in 2B, even in later, even in quest 9 of 2A, if you manage to survive until you get to quest 9 of 2A, even it starts in quest 8 also, right? Quest 8, quest 9. Maybe in 7, right? So the binary search, right? 7 onwards will start. But basically what will happen is that you will slowly start getting treated less and less as a student, but more and more as a developer, and I'm the customer, right? So I will say, give me a binary search method, right? Give me a binary search method because I'm using it in my project. And then your job is to go and build that binary search method and give it to me. But because I can't afford to test the logic of your code, I'm going to give it lots and lots of values, right? That are prone to be problematic. Right, I might give you an error. I might give you an array with no elements in it, which is possible to happen in the real world. Yes, or I might give you a big ass array, right, which may not fit, and you take it by reference or something like. So I might give you problematic input, and if your system crashes, you don't get trophies. Right, and so eventually, gradually, right. So what happens is that many people. The reason why lots of people are unhappy with software engineering in general is that they learn simple programs, safe programs at home, right? Or in school even, safe programs. And they don't get to face these corner conditions. And when they go into the real world, they'll find their code, which they are used to seeing work every time they fire it up, not work, not just in one way, like in a million different ways. Right? Lots and lots of corner cases cut in and your code crashes. And at some point, depending on how you learned your first programming, people say, there's too many things out there in the real world. The real world is not for me. I am like an idealist mathematician, right? I can't deal with this, crazy ass reality, right? So, and so they say, I'm happy with this system, but that's not the way to make a successful product, right? The fact is that all of those things were there right from the beginning. You just chose not to look at them. Right? And so you get a rude awakening, but the rude awakening really should not apply to the profession or the science. So it should just be a reminder that says, you know what? All of these pain points existed even when you were a student. But when you were a student, and you had the comfort of your parents or your guardians looking after you, you had a teacher who said, if you make errors, that's okay. It's okay for your program to crash right now, because all you're going to lose is a couple of points, which you can get back. by explaining to the teacher. So you have all the safety, you have STEM tutors, you have the college investing money in you and the government saying, go and learn, right? That time, I still had those problems and I could have faced those problems and come out alive, but I didn't, right? And so, those hours of playing Fortnite at that time are not going to help me now that I'm faced with the real problem in the real world. Because now if I fail, I lose money. I could lose my job. Yes. So this is your luxury. This is your opportunity to try lots of things and fail. So don't waste this time in doing completely safe things. You shouldn't endanger your life, obviously. You shouldn't do stupid things that could reduce the quality of your life downstream, right? Pick up crazy addicting habits and so on and so forth, right? But you should take risks and fail in as many ways as possible. Because now it's safe to fail. Nobody expects you to succeed. It's bad to fail when people expect you to succeed. Right? It's good to fail when people expect you to fail. Why is it good to fail when people expect you to fail? Because when I expect you to fail and you fail, I know that you're actually doing work. So I'm happy. So college is the only time you can make someone happy by failing. Right? I'm the only person who will be happy if you fail in programming, not in the exam, obviously, right? In the, do things and it doesn't work. I'm happy because I know, oh, this guy is really trying hard, okay? And so that's one pain you won't have to face. 15 years later, that's something you won't have to face, because then, something doesn't work. You have to go back home with a concern, right? You got a sword hanging over your head over dinner, right? You can't stop thinking about it. You can't think about what other people are talking to you over dinner. You can't enjoy your meal because you got that bug, right? However, imagine how much easier and better it would be if if you knew, right? You got the bug and oh, that's what's going on. Yeah, and let me do a quick test to make sure. Okay, that's what it is. So 20 minutes of work. Okay, I'll do it after dinner. Okay, so that's a cool thing to do, right? And lots of people do that. You shouldn't, find out what it is early on in the day, but you don't have to do it right then. Once you find out what it is, you can do it later. So you'll have the luxury of doing that. That is real freedom. That is real, then you can say you're really wealthy because you actually have time, right? Otherwise, you don't have time for doing anything. You just have time to worry, right? And that is not a good thing to do. All right, so that's what you got to do. Is everybody okay with that? In main, you know how to call it, right? So this is how you call a function in main. Go to main. On line 23, you can say long avg equals, oh, you need a vector, right? You need a vector. All right, so put a comment right in the beginning. Call srand after do the usual thing in main, right? Call srand in the beginning with time.age. No, on the first line. Go to line 22, hit enter. Yeah, enter. Okay, do srand. Call srand. No, srand. Open bracket, open parentheses. I think unsigned. Cast it to unsigned. Unsigned within parentheses. Another parentheses. Yeah, unsigned within parentheses of its own. One more opening parentheses will do. No. One more opening parentheses will do. After srand, have two parentheses.
I'm confused.
No, that's okay. So I have two parentheses there. No, after srand, put two of those parentheses. No. The reason we're confused is because the GDB, online GDB is auto-completing. Yeah, there you go. What Alexandria typed in chat. One more of those open parentheses right there. One more. You got one. Put one more right there. Turn the one into a two parentheses. There you go. Okay. Now get rid of the last one. The very last. Yeah, in the end. Right. Now that's saying unsigned by itself. That's what Alexandria typed in chat. Okay. Space. Time. TIME. And then parameter. Open. Right. Null. NULL. No, uppercase. That is the idiom, right? And you can look it up. You can just Google that entire line and close the parentheses, semicolon. That is a statement, right? We used that last class also. No, all caps, NULL.
Oh, everything, okay.
Right? Yeah. So this is the idiom, and this is how you make your program random every single time. Not truly random, but much better random. So anytime you're planning to use rand, call srand at the very beginning. Don't call it in a loop. Call it at the very beginning. Like this.
Why did you use unsigned this time?
Because the reason for that is because time returns, I believe, what does time return? time returns size t or int or some other type. However, srand expects a parameter which is unsigned. See how cool is that, right? So thank you, Alexandria, for asking that, and cut me off if I'm talking too long about this, right? So this is really cool because this is an example of the compiler looking out for us. These days, maybe it doesn't happen, but time is a function that returns, let's say, an integer, right? Which may be signed or unsigned. Maybe it's an ancient function, right? Time is actually an ancient function, as the name indicates. Right? It's an ancient function, which means maybe it existed even before the time when we had unsigned long and so on and so forth. Maybe it's a signed long, right? So maybe it returns a signed integer. However, so for historical reasons, time has always returned a long integer. Could be positive or negative. Although, negative we don't use, so that one bit is useless, right? However, srand came later. And srand said, my seed has got to be a positive number. The parameter srand takes has got to be a positive number. So what happens if you combine the return value of time as the input, the parameter for srand? The compiler will complain, right? Because it will say time returns a signed integer, but srand takes an unsigned integer. You're taking this and passing it there. So something weird is going to happen here because, this guy expects something different. Although we know it's exactly the same, because we know time is never going to return a negative integer. It's always going to return a positive integer. It's just wasting that bit. Yes? Time will always return a positive integer. It's never going to return a negative integer. So we know. However, because it is an ancient function, its signature does not communicate that fact to us. The signature of time says, I'm just going to return an integer. It doesn't say I'm going to return only a positive integer because it's an ancient function. Yes. This is my hypothesis. You can always, verify this. Okay. However, srand says, give me only a positive integer. So the compiler will complain. So, however, we can disabuse the compiler and say, don't worry, don't freak out. Everything is perfectly safe because I know time returns 4 bytes. It thinks it's an unsigned, it thinks it's a signed integer, but really it's an unsigned integer. So we'll just interpret the 4 bytes times returns as an unsigned integer because we know that even if it's a signed or unsigned, the positive is always the same. It's only the negative that's different, right? Choose complement. Right? So we say we'll take the return value of time and treat that as a signed integer, even though time thinks it's an unsigned integer, or vice versa. So we're telling that to the compiler, we're spelling it out in such excruciating detail so that the compiler will not freak out, thinking that, oh my gosh, Alexandria is going to shoot herself in the foot. Yes? So how cool and nice is that? That's why we say unsigned there. All right, so it's a long answer for a seemingly simple question Alexandria asked, but I had to go into that detail because that exposes one of the beautiful properties of the compiler. Now, I don't know if it generates errors these days, but you still have, if you have a function that takes something else, we'll come across these situations later, right? We say that thing there, unsigned within parentheses, is called a cast. It's a cast, meaning take something that's 4 bytes, which belongs to type A, right? And interpret that as type B, which is also 4 bytes. Take an apple, which is, 15 cubic centimeters, but interpret that as an orange, which is also 15 cubic centimeters. Exactly the same volume. Yeah. So like that, same thing, same size, look at it differently. This time looks at it as integer. This looks at it as unsigned integer. As it happens, it's the same because time never ends up with an integer that's negative. Does that make sense? Okay. Now on the next line, put a comment. After srand, put a comment. Yeah, one more blank line, one more blank line, one more blank line, and then a comment. Yeah.
Oh.
One more blank line and then a comment saying, right now, create a loop, write a loop to fill in. Oh, we got to declare the vector, right? Declare the vector after srand. After srand, go to the end of the srand line, end of 23, and hit enter, right? And say a vector, the same line, standard double colon vector of int, right? Standard double colon vector of int, that thing there, yeah. No, not all the way. You can do it all the way. We'll get rid of the ampersand. Okay. Yeah, paste it.
Okay. So that.
No, you can paste it. All right, now get rid of the ampersand. All right, okay. Just say, call it something. Call it my vector, my underscore vector. right? And then let's say this vector is going to be how big? Let's say this vector is going to be 100,000 elements long, right? So open parentheses, and say 100 times 1,000. No, this is what I was telling. Who coded last class? Hiram? I say 100 times 1,000. Yeah.
Anon, I have to leave because I got a class. Can someone take over?
Yeah, sure. Just share that URL with someone maybe, or just someone just copy Command A and then take
Yeah.
it over. What time is it? It's 9:32. Can someone take over from Zaid? Thanks, Zaid. Thanks so much for coding. And by the way, thanks everybody, right? All of you other guys too, right? For coding on the other days. It's great fun. But is this working out for you? You guys, right, cutting code today, and then on Thursday we talk about the code. Is that, yeah? I know I keep asking you the question repeatedly, but anytime it's not working out for you, all you have to do is just say yes, and then we'll switch modes to a different kind of teaching.
Perfect. Thank you, Anon.
No worries. I'll see you on Thursday. Okay.
Yeah, Thursday.
Someone please take his code, right? Let's not waste time. If you guys are going to be in my 2B, let's also do something like this, right? Well, let's arrange times during the week for you guys to code 2B problems, and then I can walk you through some of them. Even though 2B is going to be online, we can do this. Who's got the code now? Alexandria. Okay, great. All right, so let's add some comments. Let's add some comment. The last comment that he was working on. What was the last
One
comment?
second. I'm trying to grab his code.
Oh, you haven't got it yet?
Yeah, I suck at Zoom.
Command A. Oh, it's not letting you copy from the browser. Command A.
1 second. I think I have to quit sharing. Someone else can grab it. I suck at this.
How do you grab the code? Is this your screen, right? So this is your browser.
Yes.
So you should be able to. It's a read only. Even if it's read only, you should be able to collect copy. You should be able to select and copy.
I can't see the chat. That's the problem.
Oh no, you don't have to go to chat.
See, look, there's a fork this button at the very top left.
At the very top left.
No, inside the website, fork this.
Oh,
It's
green,
next
green,
to run.
On the left.
Oh, I see it.
Yeah. Okay, so that makes a copy that you can use.
Oh wow, yeah, fork makes a copy automatically. Well, I was just going to do that manually. Wow, this is not the code that Zaid wrote.
Oh,
Yeah, it's
I
not the
got
right-
it. Yes,
on the-
thank you, Hiram. I got it.
Oh, cool. That's nice. All right, so there's this comment that Zaid just opened on 25 that should say create a loop to fill my vector with my vector dot size with my vector underscore vector dot size open close parentheses. Open, yeah, space. Not there, space outside. Yeah, elements, random integers. Okay. All right, now you're going to do a loop. You don't do the loop now. You can do that after I'm gone, right? Meaning after I step out. You can do more things too. You don't have to do just a loop. Also, make sure that everybody's with you. Okay. Fernando, Madison, Yushin, are you all with okay?
Yeah,
with
I'm
the speed,
good.
Alexandria's typing. Okay with the speed.
Yeah.
Fernando,
Yeah, I'm here.
are you okay with the speed? Alexandria's typing at.
Yeah.
Okay, all right. If not, just respond to her by message or something, okay? In Zoom, you can send her a message. Okay, good. So you're going to do that. So just say 1 point. Well, say that's the first item for you. So number one is create a loop, right? So put a one dot right there. Yeah. All right. Now then blank lines after that. Dot maybe whatever you want. Yeah, you're going to fill that in. Okay, 2 should be call the get average function to find the average and print it out. Yeah. So now you're going to do int. Was it long? Next line you can say long average equals and so on and so forth, and you call the function. Do you want me to speak that line to you, or are you guys okay with calling the function on your own?
I think we can all do it together.
Okay, good. All right, I won't say any more then, right? And by the way, there's only 2 of these. Now, the way to experiment is that when you get the average, for a moment, forget about the size. Forget about the size of the vector, right? try an experiment without the ampersand, you know, in the function signature, without, you have the ampersand, experiment
Yeah.
without the ampersand. Now, actually write a comment there, write a comment. Let's put it in comments. Number three. Okay. Experiment without the ampersand in the function signature. And with array sizes up to 10 million. Right? And is it, are the runs getting slower or faster? And then experiment with the ampersand and compare. Experiment with the ampersand and compare. Is it a good, you know, it's like a nice little chemistry or physics experiment, right? So we say, this is experiment, this is what we want to try and do, right? And swing the pendulum and measure the time, blah, 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 right? So like that. So we've got the thing here, we've got the setup. Now you're going to do the experiment on your own. So you're going to create the, first you're going to do with the, that's your control. Your control is, everything is exactly the same, except one has the ampersand, one doesn't have the ampersand. Right? The pendulum, right? So I'm going to swing the pendulum twice, one with a 1 foot string, one with a 10-foot string, right? Everything else exactly the same. Is a period different, right? Is a period different with a 1 foot, right? And that's what we're trying to find here. So now we got the ampersand, and now we don't have the ampersand. Now we try with, you know, 10 integers, 10 million integers. Is the time different? Right? So is it a cool experiment? I am actually very keen and interested to see what the result of this is going to be. Because I've never run this, you know, frankly, I've never run this experiment in my life so far. So you guys are probably going to be the first people I know who are running the experiment that I can see. So if you find the result, I'd be interested to know. In fact, even better, if you start a Google spreadsheet, right? In a Google spreadsheet or a Microsoft Excel spreadsheet, you can say vector size, right? 10, 100, 1,000, you know, and so on and so forth, right? And then you can say with ampersand, times are, you know, 0.5 microseconds. I don't know how you're going to measure 0.5. How do you measure 0.5 microseconds? Right? So when my daughter was in elementary school and she was asked to measure the size of a, I think it was a dime. So the teacher said, get $1 worth of dimes, right? And then they stacked it all up and they measured the length of the whole thing and divide by 10. So you can find the thickness of a single dime. Yes? So how do you find the time it takes for one call of get average with only a vector that's, I don't know, 1,000 elements long? It's going to be so fast that you may not be able to measure it with ordinary time, right? You can measure it with, you know, micro time and all, but we're talking about ordinary time. So the way you do that is by saying, okay, well, you know, ordinary time is the granularity is 1 second, so I can't do that. However, I can do this operation with a, you know, 100,000 integers, maybe takes 0.5 seconds. So, but I'll do the operation, let's say 100,000 times or 1,000 times, and then divide by 1,000. If I do it 1,000 times, it takes 3 seconds. So if I divide by 1,000, it takes, you know, 3 milliseconds per call. So even though you can't directly measure it, you can measure it by measuring many of those and dividing. Yeah. So those are tricks you know find out. So here's it is. That's why I say it's computer science is you're able to bring to bear a lot of knowledge that we just learned in regular science, right? And you can apply exactly the same principles, right? It's measurement of time. It's like pendulum. So we have one control variable, the ampersand, and you're going to look at the, and so you can say with ampersand, these are the times. Without ampersand, these are the times. Oh, I got these. Now I can actually use Google or you know, Excel to plot it, right? So you can say, oh, it takes that much time. It takes that much time. Is this a different shape than the other? Does this curve and that one is straight? If it curves, if one of the lines curves, then you know that's not a good sign, right? If it curves, it's not linear anymore. It could be quadratic, right? Or even worse, who knows? So does one of them curve, or it's just linear, different slope? So all of those interesting things you'll find out, right? And why is it important to find these interesting things? Because when you're out there in the real world, nobody wants to employ a software engineer or programmer who knows only 1 or 2 ways of doing something, right? Because 1 or 2 ways you can pick up easily. You can even memorize them, right? So a good software engineer that's hireable, hire-worthy, is someone who knows many ways of doing something. Many ways, you need to know, right? Although you're not going to do it every single way, you need to know how to do it many different ways so that you can pick and choose as the situation demands. You should be able to adapt on the fly, you know, nimble, right? If you're not nimble, if you don't know many ways of doing that, you're not nimble. You're just stuck. You have to go, only one path. If that path doesn't go, you're going to keep banging your head until it gives way, right? But by knowing many ways of doing that, you can just float, right? You can just curve around obstacles and then reach a goal. So that's why it's important to do all these different ways of doing things. Is that enough? Can I just basically hand over the screen and everything to you and take off, right? Don't all take off right away, okay? At least solve 1 and 2, right? Before you go on to 3. 3 maybe you can do in your own time and share on Reddit, but at least do 1 and 2 together. Are you guys okay with that? Good. All right. So I'm going to be around, okay? I'm going to be around. You can call out to me. I'll come back and help you if you need it. I don't think you do, but it's all going to be recorded. Be mindful that Agnes and all these other people depend on these videos, okay? To learn, because they can't make the Tuesday video lecture. And so, so things that you do, other than verbal comments, try and see if you can make comments also, so that people who follow can just watch it and see. Was this helpful? Was this class useful and helpful in general? Did you guys learn anything useful today?
Yeah.
All right. Thank you. And again, I have to remind you every class, okay? Anytime you find me talking about things that are not directly relevant or useful to you, just cut me off, okay? I don't care. I don't care. I can talk to you. I can talk to you another time, outside of class hours, maybe, right? Another meeting, maybe, right? So I set up a Zoom session, 5 or 6. So I don't care. Just cut me off, because there's a lot of stuff just in CS2A that I need to talk about. All right, on that note, all right, this screen is yours. Bye.
Okay. Who wants to lead me with number 1?
I mean, just do it. We've made lots of loops like this.
Yeah, this one is really.
Size ti equals.
Oh yeah, thanks. And I think I just Googled my vector.size, and I
Yep.
think we actually have to have elements in it. So maybe like this.
Do we? I don't think so. No, that's
No?
not right.
Okay.
The call, I believe, from last class was to determine the size of the vector, the initial
Well,
size.
just run this and see if it works, and then we'll know.
Okay.
My
Oh
mic
gosh,
working?
no, don't do that.
Okay, let's try this.
Is my mic working?
Yeah, it's working great.
Yeah,
Alright.
it's okay.
Cool.
Okay. Oh, you
Oh,
forgot that it's
standard.
STDCI. Oh my
Oh,
gosh. The
I
namespace.
Oh gosh.
Okay, it works. This time.
Yay. Okay.
And let me get rid of it.
No, run that. Just
Okay.
kidding.
No, let's not run that. Can I just do this? Will this work?
I equals. I think it would.
I don't know. I'm still
Does
not
that sound okay?
100% with vectors.
Yeah, me neither.
Does this look okay, guys?
I think it should work.
Okay, I want to see out, so we'll just.
Oh yeah, if it crashes, it crashes.
So I split it into 2
Oh,
without amp
oh
and
no.
with amp.
Oh,
and
I
I'll
see.
just-
But
we
both
can-
of them. Okay.
We can implement one and then probably copy paste.
Okay.
True.
Okay, so, long and, okay.
Where's size T?
Is
You
everyone?
need to name it.
You need to name
Size
it
TI.
I.
Oh, why am I doing that today? Okay, and then, will this work or?
Size. I think it should, right? Well,
I
unless
haven't-
I really
like-
don't understand like what the heck the ampersand thing is.
The and means we're passing in like a reference.
A pointer, right?
Yeah, like
Yeah.
to a
So
memory.
it should. I don't know. Should it be fine? Because
I have
it's
no
pointing
idea.
to an object.
But
But I
back to
don't-
Java. This is what I know. Pointers.
Yay. Oh, and get rid of the stub at the end.
Got it.
Yeah.
All right. Well, we can at least see if this does something, right? I mean,
Yeah. Let's see if it does something.
he likes it when we tag them. And then,
Oh, namespace.
oh, Do we have to do like at my vector? Or-
Don't know.
Probably
doubt-
since we have to pass in the. Well, I don't know.
Let's see.
Okay, so vec size is not declared in this scope. Where did I put that? Vec dot
Oh,
size?
where'd you put vec underscore size? Oh, there it is. Vec underscore size. Go up, go up, go up. Look, you're
Oh.
returning.
Oh, there, yeah.
Man, my typing today. Invalid initialization.
Yeah, okay.
At 41.50.
So down here,
Yeah.
Yeah, I would try it without the
Just,
ampersand.
yeah, try it without the ampersand.
okay. Let's see.
All right.
This is
Promising.
better.
Oh,
Hey,
yeah.
it worked.
There we
No
go.
way, it
Okay, so
worked.
you don't need to put the ampersand when you're calling it,
This
even if
is
it has the ampersand.
amazing. All right, let
And-
me copy this.
The ampersand does not mess with like the functions of it. Like we can still call
Yeah.
vec.size on it. That's good to know.
Beautiful. All right, thanks, guys.
Do you keep doing Control S?
Average with amp. Yeah, I keep doing control.
Yeah, I
F,
feel
you know,
that.
yeah.
Oh,
It's a habit.
Yeah. Oh, it's a good habit to have. It's just
I save after like every line of code. It's
Yeah.
terrible.
it's better than not saving ever.
yes, definitely.
Sorry, I'm going so fast. If this is
No, this is great.
confusing anyone.
I like the speed.
Me too. Okay, because it's 9:48. So
Okay.
Oh,
Oh,
Don't
dang
forget
it.
the
namespace.
Freaking namespace. I'm dying.
okay, so
Yay.
then
Okay, now we need to
ideally-
compare speed, right? So like maybe we have to do them one at a time. We can't do them both.
So I can only be here until 10. Can we do like a timer? Like, is there a timer in C++? And we can.
I mean, I can
I would
also
guess
just
so.
keep track of time.
Well,
We
either way,
have
like if we make it big
time.
enough, there should be like
Yeah,
a big
let's make
difference.
it big enough and time it. So let's just.
Yeah. Okay. With
Okay,
ampersand.
let's make it really big.
100 times. Oh gosh. Remember he
that
likes to
okay?
do the 1,000, so I would do like
Yeah.
1,000 times 1,000 or something.
Okay, that's
1,000
easier
times
to-
1,000. And then maybe like another 10 or something, so that we
Yeah,
get
10
10 million.
times 1,000
10
times
million.
1,000.
There, now we have 10 million. Lovely.
There we go.
Okay. Well, actually, the problem is compiling.
Oh yeah.
It's
there-
still way
there-
too fast.
Okay, now now try the without ampersand one. So comment out the. No. Wait, what?
Oh,
Wait,
the
why would you do
answer.
that?
It's fine.
Sorry.
Why would
I
you do
was
that?
thinking the modulo.
Oh, yeah. Okay, so we want to try that
Maybe-
one and ignore the one with amp and see if it's like a lot slower. Oh gosh, I think it
Oh,
is.
it is slower without the ampersand. I
Yeah, because it
swear
has
it's
to make the
slower.
copy, right? Yeah,
Yeah.
that makes sense.
Wait, is it?
No,
Is
yeah,
it?
without ampersand is so much faster.
Wait. What are we doing now?
Okay, I think we need to add more. I don't think it's.
Yeah, more.
A trillion.
We need more. Oh,
What?
Add it. Ooh, ouch.
Oh no. Oh no. Oh wait, he did say up to 10 million, didn't he?
I can't tell
Oh, it
what's
worked.
faster.
I think it's slightly faster.
Wait, we have to do them one at a time, otherwise like we can't really tell.
No, but we have to stopwatch it pretty.
Well,
Ah.
we have to do them one at a time. Yeah, let's
Can't
see
we
if there's a
use the
timer function.
time function.
Let's use it. Let's use the time thing that we have, and then
Yeah,
try
don't
to
we
figure it
literally
out.
have time since we're doing random?
Yeah,
Did
we're doing the
include
time.
We-
So
why
so
didn't we have to include time? That's kind of weird.
let's just like at the same time. Wait, let me see what time does. Let me see what time does.
Yeah, can we like save
see.
time? So like
Can we save time?
start with amp equals time. No idea.
Dang it, that's annoying.
Would that work?
Huh? Wait, why are you doing time null? Wait, I don't know what this is. Dang it. Does anyone know what time
Yeah,
actually
like-
does?
I'm gonna like subtract and then do like time no minus start with amp. I don't know. What will that do?
Time should return a value. As long as the argument isn't null.
It's 0 though. It's 0.
So time
Yeah, that's 'cause
returns a
you're
time t object.
Putting null into it.
Yeah, apparently, I don't know how to use this time thingy. It's
We
really
could always
weird.
finish this on Thursday and
Where?
we'll just
Use
share this.
Program timelines.
Hold on. According to this is what it wants.
Did you put it in chat? I can't
Yeah,
see
let me
chat.
post it.
Sorry. Someone's gonna have to read it to me. It's just gonna give me zeros with this. Okay. Hey, it actually did something though.
Yeah, but I think those look. So the problem with time, the time function is that from what I looked up about it,
But
in
it's
the
using
reference library,
seconds.
Seconds
it uses
is bad.
calendar time, like
Yeah.
actual time, and it
Guys, I'm
apparently
sorry.
needs some
I
sort
have
of.
to. I have to go. Can I post this on the Reddit, and then we can finish Thursday? Or do you guys want to continue?
I have to go too.
Okay.
Yeah, so it's
Yeah.
probably best if we just finish Thursday.
Yeah.
Okay, I'll put it in the chat in case anyone wants it.
But I did find this. I'm not sure if that's what we want to use or something like that.
Oh, a timer. That sounds good. Okay, we can like do this Thursday. I think
Alright.
it's pretty good. Sorry if I went too fast for anyone. We were running out of time.
Alright. Are we allowed to like leave?
I think so.
Okay.
Yeah.
Alright.
Okay,
Thank you
I'll
for
post it on the Reddit.
Bye.
yeah.
Sounds
Bye
Bye.
everyone.
Bye.